Hi everyone, and this is multi-step reactions. So we are going to be taking those single-step reactions and putting them together in a particular order to get a final molecule. So we can use 2 steps or more. And the 4 reactions we're actually going to use, even though there's 6, the only ones we're going to really need are addition. Remember, with addition, we're looking for starting materials that have double bonds. If we don't have double bonds, we can't use addition. We can use substitution, and substitution, why am I spelling this? Substitution, oh my gosh, what's happening? There we go, substitution. This is going to be single bonds, and this can also be benzene. Benzene acts like single bonds even though it has double bonds. We can also do an oxidation, and we're going to do oxidations of alcohols, and we can also do an oxidation of an aldehyde to turn it into a carboxylic acid. And lastly, we'll do condensation. And we'll use condensation to make esters and amides and ethers. So we aren't going to do combustion or elimination. They don't really progress a reaction. They're sort of dead ends. So these 4 reactions we'll see used over and over again, sometimes more than once in a sequence to get the job done. Some hot tips when we're working through these problems, because these problems can be a challenge. The first one is to sketch the product so that you know what you're trying to make. That's a really good hot tip. If the product is made through condensation, so if I'm asking you to make an amide, an ester, or an ether, I want you to do the last step first. So you're basically going to show me the 2 ingredients that are needed for the ester, the amide, or the ether. This will make more sense when we're actually doing this type of question. And then lastly, there is a flowchart on page 83, which I'm going to show you, that may be helpful. The more you understand or recognize the individual options, the 4 types of reactions, the easier it is to do without a flowchart, but some people find the flowchart is very convenient and easy. So here's what the flowchart looks like, and I'm going to show you how to use it when we're doing problems. I'll go back to it and show you how we can use it. But again, you may find that you don't need this flowchart, but it's here if we need it. So the first one we're going to do is we're going to make propanoic acid from an alkane. So again, my first tip is to sketch what I'm trying to make. So I'm trying to make propanoic acid. So propanoic is 3. Oic acid is this functional group, double bond O, OH. So that's my final goal, and I'm going to start from an alkane. So the alkane I'm going to want to use is going to be a 3-carbon alkane, since the final product has to be 3 carbons. So let's just start with our 3-carbon alkane, and I'm just going to use sticks for hydrogens. It's a really quick way of using a short form, just to make our process a little bit faster. So if we consider what are my options here, the only thing I can actually do here is a substitution. It's the only of the 4 things that I can do, the 4 reactions, it's the only one that I actually have. And the only thing that I can substitute a hydrogen for is a halogen. So really, I only have one option here. I'm going to target this hydrogen right here, and I'm going to add a halogen of any type. So I'm going to add an HCl. It could be a diatomic halogen, but I'm going to do this one here. And I'm going to substitute a halogen for a hydrogen. So this is always the first substitution. If you don't have a halogen, that's the only thing you can do at this stage. And once our halogen is on there, we're going to have a byproduct of H2 here. Once the halogen is on there, now I can take this product that I make and I can do a second step with it. Now that the halogen's on there, I can substitute for bigger and better. Going back to my goal of that carboxylic acid, think about what I want to add and substitute the chlorine for. We've seen substitutions before, and you can also think about, how do I make carboxylic acids and what ingredients do I need to make that? So I'm going to add water next. Again, that's my only option here. I can't actually add a carboxylic acid group in one fell swoop. I'm going to have to add it in pieces. So now that the halogen's on there, I can swap it out, do a better swap, and that'll put the OH in place. I'll have a byproduct of HCl once again. And then the next step is to take what I've got going here and decide what to do with my alcohol. So again, going back to my end goal, I'm making carboxylic acid, and I make carboxylic acids by oxidizing an alcohol. When I oxidize it the first time, remember it makes an aldehyde. I don't have to show a byproduct here, so I can actually show the next step straight away by oxidizing a second time. And this is what turns it into a carboxylic acid. So that's how we turn an alkane into propanoic acid. Let's have a look at how the flowchart may have been useful. So the flowchart, we started with an alkane, and if you have a look, we ended with a carboxylic acid. So if you look at the steps that we used, they're the same steps that I just did. We did a substitution with a halogen, that's what X is, to make an alkyl halide. An alkyl halide is just a carbon chain with a halogen on it. Then we substituted with water and we turned it into an alcohol. Then we oxidized once to make an aldehyde, and then we oxidized a second time to get that carboxylic acid. So the flow chart, if you think about or sort of isolate where am I starting and where do I need to finish, actually shows you the proper path and what to do. So that's how you can use this flow chart. Every arrow represents one of the steps. You'll notice there are 4 arrows and there were 4 steps needed to make this particular compound. All right, let's try another one. This one is making N-methylaminopropane from ammonia and alkanes. So again, our first goal is just to draw what we're supposed to be making. So let's start with our propane. 1, 2, 3. We're making an aminopropane, so no number means N is on the number 1. And we have to have a methyl on there. So that's our sketch, and we're starting from ammonia and alkanes. So really basic starting materials. I have 2 alkanes that I'm going to need here. I'm going to need a 1 carbon chain, and I'm going to need a 3 carbon chain. I always start with carbons. This is carbon chemistry. So the biggest mistake here is that students try to do reactions with the nitrogen. The nitrogen's going to come along for the ride, but all the reactions are carbon-based reactions. Remember, it's organic chemistry. I like to start with the small carbon first, and then the larger carbon second. So what I'm going to start with is an alkane, and the first one is just 1 carbon big. So that's what I'm going to start with. Again, if I think of my 4 reactions, there's only one thing I can do, and that's a substitution. And again, there's only one thing I can substitute, and that's a halogen. So the limitations are actually helpful. Let's do a diatomic halogen this time. And I'm just going to, it doesn't really matter here, but let's tackle this H. I just want one of those H's to come off, and I want a halogen on because I want to be able to get a nice reactive carbon here. We have a HCl as a byproduct. Now that I've got that nice reactive carbon, now I can swap it out for something better. And if I go back to my structure up here, the something that I want is a nitrogen. So let's take our ammonia. I'm just going to do it structurally so we can see how it goes on here. You've seen me do this with single step reactions, but I'm going to have to leave one of the H's behind, otherwise I'll have too many bonds here. So I'm going to swap that chlorine for a better substance, the ammonia in this case, and so I'm going to have my NH2, you can collapse it if you want to, attached to my NH3, and it will have that HCl byproduct. So I've actually, going back to my original sketch, I've actually created this whole upper part here. Now I'm basically going to do the exact same thing with the longer carbon chain. So let's see that. So I'm going to work with the longer carbon chain at this point. Again, I'm working from an alkane. The only move I can do here is a substitution. Again, I can use anything here, but it has to have a halogen. So let's use HBr just for fun. And the hydrogen I want to target is right here. So if I go back to my original compound, my sketch, then the nitrogen has to go on that first location. So that's the hydrogen that I'm going to target. So I substitute a halogen into that spot where I want the action to happen. And I have an H2 byproduct. Now that I've got that on there, now I'm going to bring in that compound that I just made. So my NH2 phosphorus, my NH2CH3, that's what I'm going to substitute. So I'm going to take everything but one hydrogen, and I'm going to substitute again. This is just substitution after substitution, as you can see. That's always how we make amines. So now I'm going to have an N with an H and a CH3, and again I've got a byproduct of HBr here. So just substitutions. If I have a look at my flowchart, again, I was starting with alkanes and I want to make amines. And again, it tells me how to do this. It tells me I have to substitute. X's are halogens, so it tells me I'm substituting with halogens to make halogens with carbon chains with halogens on them. And then I'm adding ammonia to turn them into amines. So that's essentially what I'm doing. In this particular case, I had 2 carbon chains, so I had to do this sort of process twice almost. All right, this one is a big one. We're going to make ethyl propanoate from propene and ethane, and we're going to use our tip, one of our hot tips, that anything made by condensation, which is an ester, an amide, or an ether, we're going to do the last step first. And this is an ether, or an ester rather, so we are going to do the last step first. So I'm going to put our arrow in, and I'm going to sketch our ethyl propanoate. So there's our ethyl propanoate. Water is our byproduct. And then what I'm going to do is I'm going to work backwards here. So I'm going to split up my ester and I'm going to pull it apart, and I'm going to put the water back in. So this part has the O, so I'm going to give it the H of the water. And then this part, I'm going to give it the OH. And the reason why this is a really important thing, because I can now see the 2 ingredients I need to make my ethyl propanoate. So when I go back to the starting ingredients I've been given propene. Well, propene is going to be used to make propanoic acid, and I've been given ethane. So ethane is going to be used to make my ethanol. So that will be my goal. I'm going to take propene and make it into a propanoic acid, and I'm going to take ethane and make it into an ethanol. Doesn't really matter where I start. I'm going to start with the propene. 1, 2, 3. And it's a propene, which means the first one is the double bond. And from here, I'm going to decide what to do. So the propene I need to turn into a propanoic acid. And because I'm starting with double bonds, I have to do an addition reaction. So if I look at my end goal, I need a C double bond OH, and that's a carboxylic acid, and I make carboxylic acids through the oxidation of alcohols. So really I want an alcohol here. Here is where this is a little bit tricky. Most of you are going to say, oh, I'll just add water. Away we go, because we know adding water here will put an OH group on. However, let me show you, and don't write this part down, but let me show you what happens if I add water here, because that is the natural tendency, the natural move here. So when I break open the double bonds, have a look at what's going to happen. Haha. So the OH is going to go on the second carbon, and that is Markovnikov's rule, foiling us. So in fact, this is not the move we want to make, because I need the action. If I go back to what my end goal is, and it's that carboxylic acid group, I need the alcohol to end up on the first carbon, not the second carbon. And Markovnikov's rule is going to do that to me every time. So let's get rid of that, and let's go back to this material and decide, okay, if I can't add the alcohol, if I can't add the water, what can I do? Well, Markovnikov's rule is going to get in the way. So the best thing you can do is to get rid of your double bond. I can do an addition of a hydrogen, and that's exactly what will happen. Now the benefit of doing that is because now, instead of doing addition where Markovnikov's rule is going to foil me, now I can do substitution, and substitution is very handy because I can substitute where I want. So now I can target the hydrogen on the first carbon with any sort of halogen, and then I can do a swap where I want to swap. So that's the benefit here. So the chlorine will go where I want it to go. I'll have an HCl byproduct here, and now the action is taking place where I want it to be. Let's go a second step. So now that I've got the halogen there, now it's time for water, because I can substitute the OH for the chlorine, and I can put that OH group on there. And I'll have an HCl byproduct. Now that that OH is on there, now I'm in business, because I can oxidize once to turn it into the the aldehyde. And I can oxidize twice to turn it into the carboxylic acid. And I've now made the first ingredient. Well, technically the second in the order that I did them. So I've made the one ingredient that I need. So I now have this piece of the puzzle. So now the next step will be to turn the ethane into ethanol. That's actually the easier of the two things. So starting with ethane, again, there's only one move to make when I have single bonds like this, and that's a halogen of any sort. So let's do HI. I keep switching it up on you just because I want you to see that you can do that. And again, I want the action to take place right there, so I'm going to target that hydrogen, and it's going to turn it into halogen there, and I'll have some H2 left over. Now that I've got that halogen on there, now I can substitute for something better, and that something better is going to be my water, HOH, so that I can substitute and create that alcohol that I want to make. And now I've just created the second ingredient that I needed, and now that I have those two ingredients, I can put them together, and this will be the very last step. Once I've made the two ingredients I need, I'll put them together and turn it into the ester and water. In terms of the flow chart, you can see that we started, here is our end goal and our starting place. We started with an alkene in one sense and an alkane in the other sense, and we needed to turn them into different things. So starting with, let's get rid of the last one here. Let's just start with the alkene. The alkene we had to turn into a carboxylic acid. So we took the steps of doing addition. Now, normally we would say do an addition with water. We would go straight to the right to make an alcohol. That would be the quickest way to go through this pathway to get us to carboxylic acids. But unfortunately, we had to take the scenic route. We had to add H2 first because of Markovnikov's rule, then add a halogen, then add water to make an alcohol, then oxidize once, then oxidize twice. So that was our pathway to get to the carboxylic acid this time. And then we also, of course, need an alcohol. And this one was created by starting with an alkane. Again, we substituted with halogen, we substituted with water, and that got us to the alcohol. And then the last two things are taking the carboxylic acid and the alcohol and putting them together to make the ester plus the water.